were looking at the projectile motion and we solved some of the basic problems. Now we'll go ahead and write some of the equations first, then we'll apply the equations to solve the remaining problems. Okay, the first concept is about the time of a flight. Right, this is the total time taken for total time taken by the projectile right from the beginning till the end of flight. That's the total time of flight. So denoted by T. Okay, that is total time of flight. T is equal to 2 times U into sine theta divided by G. Right, U is the initial velocity, theta is the angle made by U with respect to the horizontal, that is a projection angle, and G is the acceleration due to gravity. Okay, so 2U sine theta by G is the equation. Okay, then the next thing is the maximum height. That is denoted as H equal to U squared sine squared theta divided by 2G. Then another one is the horizontal range. R is equal to U square into sine 2 alpha divided by G. Okay, right, now okay, right, let's use this these equations in addition to the yesterday's equations and solve some more problems. Find the angle of projection of a projectile for which the range and height are equal. So it means the range is equal to the height. This is what is given. Equation for range is U square sine of 2 theta divided by G should be equal to U square sine square theta divided by 2 times G. So U square cancels, G cancels. All right. So sine 2 theta, we have sine 2 theta representation as 2 times sine theta into cos theta should be equal to, here I have sine square theta, out of which one sine will cancel, right? So this means divided by 2. I have a 2 here. So this 2 goes to other side, that is 4 is equal to this side sine theta by cos theta. So that is equal to tan theta. So theta is equal to tan inverse of 4 in radians. Okay, so this has to be tan inverse of 4 radians. So that is 89.75 degrees. Tan inverse of 4, sorry, not in radians, my mistake. This answer is 75.96 degrees. Is the required answer. Okay, next question. Next question. Article projected with 72.9 meter per second at 39.76 degrees to horizontal. You are supposed to find the range, the maximum height, and the time of flight. Straightforward, simple substitution type of equation. So it is given that u is equal to 72.9 degrees meters per second. Okay, that is, the theta is 39.76 degrees, and we'll take g is equal to 9.8 meter per second square. All right, so use this and calculate. The first you find the time t. T is given by 2 times u 72.9 into, this is sine of 39.76 divided by, this is 9.8. is 9.514 seconds. Right, then we'll calculate the maximum height. H is equal to, this is U square, that is 72.9 square into sine square of 39.76 whole divided by 2 into 9.8. Okay, 173.3 meters. Okay. All right, then find the range, that is R is equal to U square 72.9 square into sine of 2 times that alpha, 39.76 divided by G, that is 9.8. Okay, 533.27 meters. All right, then okay, then we'll write the equation of the trajectory of the projectile. Right, so the displacement along y-axis is y is equal to right. Right, this is x into tan alpha minus, okay, alpha is theta. Okay, we'll use theta here. So this is x tan theta minus g times x square divided by 2u square into, this is 1 plus tan square theta. Okay, this is the equation of the projectile. Right, so this is the path traced by a projectile for a given value. All right, so let's try to write an equation, solve a problem based on this equation. Okay. If the u is equal to, this is 45 meter per second, theta is equal to 28 degrees, right? Find the equation of projectile motion. Okay, so we just have to substitute everything over here, y and x as it is. So x as it is, this is tan 28 degrees minus g, you can take it as 9.8. So this is 9.8 x squared divided by 2 times 45 squared into, this is 1 plus tan square of 28. All right, so this becomes equal to 0.5317 into x minus, let's calculate this, 1 plus tan 28 square divided by 2 into 45 square. Okay, so this is 3 into 10 to the minus 3 x squared. Okay, this is the equation of the projectile. So at any point x, what's the value of y? We can calculate in this. Okay, right. Let's move to the next question. And the velocity required initially to reach a maximum height of 100 meters with projected at 25 degrees. So they have given theta is 25, right? And the height is given at 100 meters. What is u is the question. So need to find u such a way that, right, the height is 100 meters. So we know that this is u square sine square theta divided by 2g is equal to 100. Let's take g as 9.8. Okay, so this means we need to find out the u now. So u square you can keep as it is. U square is equal to 100 into 2 times 9.8, 2g divided by, this is a sine square of 25. Okay, this u comes to be 10,973.86. So I want u, so find the u. That is, u is equal to 104.75 meter per second. All right, next question. Find the initial velocity to get a range equal to 900 meters. Okay, so the range required is 900 meters. To get a range of 900 meters, if projected at 71.5 degrees with G equal to 9.8. So need to use the range equation now. R is equal to U square sine 2 theta whole divided by G, and this value is given as 900 meters. So U square is unknown. U square is equal to 900 into 9.8 divided by, this is sine of 2 into the alpha value, theta value, that is 71.5. Okay, so 900 into 9.8 divided by sine of 3 into 71.5. So U square is 14,655.67. So that means U should be 121.06 meter per second. Okay, next question. Find the angle of projection required to fly for 11.28 seconds with initial velocity of 136.9 meter per second. Theta is equal to 23.81 degrees. Okay, next question. Find the relation between maximum range and maximum height when theta is equal to 45 degrees. Here you have to find what is the relation between H and R given that theta is equal to 45 degrees. Right, so we need to write first the equation for R, right? What is the equation for R? In order to find the range of a projectile, R is equal to U square, right? So sine 2 theta divided by G. But theta is given as 45, so this becomes U square sine 2 into 45, that is 90 divided by G. So this is simply U squared by G. Okay, this is the maximum range. Okay. Similarly, they are asking maximum height. So I can denote this as R max. Similarly, H max is, once again, we are calculating using the similar notation, that is U square. This is sine square 45 divided by 2G. Okay, so this is U square. Sine 45 is 1 by root 2. So this is 1 by root 2 square. Sine square 45 is 1 by 2. So I can write as 4G. Okay, because there is a 2 in the denominator. Sine square is also 1 by 2. So 1 by 2 is 4. Okay, this is first, this is the second. So they're asking what is the relationship between R max and H max. I can see that I will divide. So R max by H max, you can divide. So numerator is U square by G whole divided by, this is U square by 4G. So U square cancels, G and 4G cancels. Okay, so this is 1. So this is R max is equal to, now we can see this 4 goes to the numerator, this is equal to 4. So the relationship is nothing but R max is equal to 4 times H max. So relationship between R and H when theta is equal to 45 is range will be 4 times the maximum height. Okay, right. Next question. Find the angle of projection where the height is 1 by 4 times 1/6. Height is 1/6 times the range. So have to find the angle theta such a way that the height of the projectile becomes 1/6 times the total range. So the required equation is the height is equal to 1/6 times the range. Equation of height is nothing but u square, this is sine square theta divided by 2g should be equal to u square sine 2 theta by g, right? So u square anyway it cancels, g kuda cancel agutte, but there is a 1/6 now with us. Okay, so ultimately sine square theta by 2 equal to, this is sine 2 theta by 6, right? So sine square theta hage itkoona, so sine square theta is equal to, so 3 sine square theta is equal to 2 sine theta cos theta. So sine cancels, that means sine theta by cos theta, that is tan theta is equal to 2/3, right? So this means theta should be equal to tan inverse of 2/3. Okay, so that means $33.69. Okay, this is the required answer.